Okay, so in this video, we are going to be talking about our constant rules. And our first constant rule is just the constant rule. I'm going to write this in black. The constant rule. And this shows us that, say we have y is equal to any constant c, then we know that dy dx is always going to be equal to 0, which makes sense. There's no x term, there's no slope. This is just, the graph of this is just going to be a straight line. Uh, Makes no sense. Okay? Obviously, the derivative is going to be 0. The next constant rule is the constant multiple rule, which tells us that d over dx of k, which is just our coefficient of x to the power of n of a power function, is equal to k times nx to the power of n minus 1. Now, I would just like to point out, this does not only work for power functions, this works for any function. If you have k f of x, and you are getting the derivative of this, you can just pull out this k, and it's equal to k times the derivative of f of x. This works for everything. I feel like this is most easily shown within linear functions, as say we have y equals x, then we know that dy dx using our power rule is going to be equal to 1. But say we have y equals 2x, then using this rule, we could pull out the 2, and then we just multiply it with the same dy dx here, and we get our dy dx equals 2. And using calculus logic, this may seem a little confusing, like, oh, what, he did that power rule so fast. But if you think about what you know about math from Algebra 1 or Algebra 2, we know that our m term right here, our coefficient of our x, is just our slope. That's just what it is. And we know that instantaneous rate of change is also our slope, so it makes the most sense, or it's the most intuitive in linear functions where we can easily see this, and this is also the reason why you would multiply this and not have any complications in all other functions.